Welcome back, folks. Today we're going to talk about nutrient resources. Most forests are not fertilized, so we're going to talk about how they conserve nutrients. We're going to talk about how we can utilize animal manures for crop production. We're going to talk about various sources of fertilizers and how the macronutrients are supplied, and fertilizations. First, let's talk about, you guessed it, manure. How exciting! So, the benefits of manure are that it's a great way to cycle soil organic matter as well as to build long-term soil organic matter. And the type of organic matter that we're adding in is high in nutrients and usually also high in micronutrients. In fact, usually we apply manure based on the amount of nitrogen, phosphorus, and various micronutrients. Manure is required to have a nutrient analysis done before application. Manure management requires knowledge of application and handling. Animals don't stop going to the bathroom, so a lot of times this may require daily spreading into nearby agriculture fields, depending on whether it's a liquid versus dry storage, which is why you see lagoons near concentrated animal feeding operations, which help store it over long periods of time. All of this requires water quality permitting, which requires extensive legislation, permits, knowledge, and training for the operators. You can't just willy-nilly build a pond and fill it with poop, folks. I know, you were thinking you wanted to, but you actually have to go through an extensive permitting process in order to store a bunch of poop in a pond. Pretty exciting, huh? The organic sources of plant nutrients come from these manure applications. However, if they are mismanaged, we could have potential excessive volatilization into the atmosphere, runoff into nearby water, and so all of this has led to nutrient management plans for these kinds of production facilities. And that's why we have a permitting process to make sure that the people in charge of these facilities are protecting nearby resources. Look at this chicken. Cute. So, in the fall, this is a great time for pasture hay or cover cropped areas. Winter, not the best time because the ground is frozen and the microbes that break this down aren't active. Spring is the best time for summer crops. Summer, unfortunately, is a little hot and we can lose a lot of nitrogen to ammonia volatilization. So we want to apply closest to the crop needs if possible. However, as you may recall, animals don't just stop pooping in winter and summer. So we have to have long-term storage for these applied nutrients. All right, biosolids, aka sewage sludge, aka your poop. Yes, they actually collect your poop and sell it. You had no idea that your feces were so popular and valuable. But Milorganite has been doing this, and Louisville Green has been doing this since the early 1900s. That's right, folks. Look at that adorable child holding a bag of her own feces. Now, the limitations of using this as a source for plant nutrients are that because humans take a lot of vitamins, our feces tend to be very laden in heavy metals. And the nutrient content tends to vary. And so, in order to utilize sewage sludge, you are required to have an analysis, a complete analysis of the nutrients involved in it before it can be applied. And it's also treated before it is allowed to be sold. So it's no longer biologically active, shall we say. Now, inorganic commercial fertilizers, including nitrogen, generally come from these forms. I would say the most popular is anhydrous ammonia. Urea is one that's popular, but it's very cheap and it's also very inefficient. It volatilizes a lot. You also see people using ammonium nitrate or a urea ammonium. Phosphorus usually comes in the form of monoammonium phosphate, diammonium phosphate, or triple superphosphate. Potassium is usually applied as a muriate of potash. Potash power, people. Or you can also apply it as potassium sulfate, and generally that's utilized if we have a sulfur deficiency. Now, we're going to talk about how to read fertilizer labels. Now, this is very important, folks. There are 3 numbers listed on every fertilizer bag. Now you're going to be looking for these every time you go to the store. The first number, and in this example, the number is 20. This first number is always indicative of the amount of nitrogen as a percent. All right, so nitrogen is a percent. So in this bag, we have 20% nitrogen. The second number in this example is the number 5 in the Go Green fertilizer. This is phosphate. Now, it is not phosphorus, it is phosphate, and we'll talk about what that means in a minute. The third number is always going to be representative of potash, K2O. And in this example, we have 10% potash in this bag. Now, let's look down here at Scott's starter fertilizer. We have 20% nitrogen, 27% phosphate, and 5% potash. So, when we're trying to figure out how much we actually have in this bag that we're going to apply, it's really easy to figure out how much we have of nitrogen because there's no conversion needed. It's straight nitrogen, 20%. However, phosphorus is indicated as phosphate and not phosphorus. But don't worry, the equation to figure this out, to figure out how much percent phosphorus is very easy. You take your percentage of phosphate and you multiply it by 0.44. So if I ever ask you, what is the percentage of phosphorus in this bag? You would say, there's 5% phosphate, and I need to multiply it by 0.44, so I'm going to get out my calculator and do that. So 5 times 0.44 equals 2.2% phosphorus. Now let's do the same thing for K2O. But for K2O, or potash, if we want to convert that to the percentage of potassium, we multiply it by 0.83. So in this example, we have 10% potash, and we need to find the percentage of potassium. So we're going to take 10 times 0.83, and we end up with 8.3% potassium. And yes, folks, those will be multiple choice questions on the final exam. Now, remember how we talked about Liebig's law of the minimum, which basically says that your most minimal, least amount available nutrient is what's going to limit production, because that's what's going to cause a deficiency? Well, when we find out we have a deficiency, we hire someone who is a soil fertility diagnostician, basically a detective, to figure out the fertilizer that will be effective. Yes, that rhymed. You're welcome. Basically, we can analyze plant tissues and soil and figure out how much fertilizer we need to recommend to be added. Here we have sufficiency ranges for tissue analysis of selected plant species. You don't have to know these. This is just for fun. So let's say we took a clipping of a corn leaf at tasseling. We would want that corn leaf to have 2.5 to 3.5% nitrogen to be growing healthily. To not have any deficiency issues, that's the range we want to find it in. So, if we're going to go ahead and take a soil test, we're going to sample the soil, we're going to send it off to get chemically analyzed, and then we're going to interpret the results and make a recommendation on the kind and amounts of nutrients to supply. Usually, we take our soil samples at about 6 to 12 inches depth, basically the depth of the rooting system. Now, I'm going to skip this slide. I'm going to skip this one too. Hey, skippity skip skipperoo. All right, now let's talk about diagnostic tools and methods for assessing soil fertility. The first thing that we can do is just make some observations. Do the plants look yellow and sad, or are they thriving? Write it down. Do some soil testing. Get yourself a plant tissue analysis to find out what's actually in the plant tissues compared to what's in the soil. Make sure you keep an organized record of your observations. Interview the former landowner or manager. Look for spatial patterns. Does the same spot in the same field always have an issue? Maybe something needs to be addressed there. Examine your plants, especially the leaves, for nutrient deficiency symptoms. Measure the shoot and root growth and check for symbiotic associations, especially in your legume plants. You might need to inoculate them with the bacteria because there might not be enough there in the soil naturally. When we're testing our soil, this is usually your weakest link, by the way, we're going to basically take about 12 to 15 samples per 10 acres and we're going to mix them up in a bucket to basically cover that whole area. And this is called a composite sample. The depth depends on the type of crops that you're growing, and we always want to sample the same time every year, usually at the start of planting season. But usually you're going to do this about 6 to 12 inches depth, depending on how deep your roots go. Your chemical analysis is your next step, and then you've got to interpret the results. Usually you can pay someone to do this for you. Soil testing might lead you to pre-sidedress nitrate. Now, what this basically means is that when the plants are about a foot tall, we take another round of soil samples to figure out if they have enough nutrients. Because at this point, we can still do something about it. When the plants get too much taller, we can't do much about it and we lose yield. So a lot of people pre-sidedress nitrate. Here is what a result will look like from your soil testing analysis. Now, this is for John and Jane Doe of Doe Farms. How nice of them to share. They're using corn with conventional tillage. Maybe they're thinking about moving to no-till though. That would be nice. Their pH has come back at 5.2. This is a bit on the low side. They might consider liming next year. Phosphorus, oh, they've got plenty of that. Too much even. Potassium, they're right in the medium area. They might need to add some potassium. Magnesium's pretty low. Definitely would recommend adding magnesium. Their calcium's pretty good. They're right at the bottom of the optimum range. Probably not going to pay off for them to add calcium this year, but in future tests, if it comes out low, they'll probably want to add some. And here at the bottom, they have some recommendations on what they need to add to bring these levels up into the optimum range. Now, there's a soil test result yield that basically helps you to figure out if it's profitable to add that nutrient. Now, if you're very high or excessive or high, it's not going to be profitable to add a nutrient. You already have too much of it. Why would you add more? You're really just pissing money into the wind. However, if you're very low to low, the cost benefit of adding that nutrient, of course, is going to pay off because you're going to get a yield response. Plant tissue analysis ultimately ends up being an important tool for planning, and seldom can you correct your current year problem, but you can figure out what you can correct for next year. This also basically tests for the sufficiency range or concentration within the plant tissues. Another thing that you'll learn in some of the upper division soils classes are that nutrient ratios can be really important, especially in rangeland where we're grazing. For example, if we have a low magnesium to potassium ratio, we might see a lot of grass tetany or what's called staggers in cattle, which is a nutritional or metabolic disorder. Sufficiency ranges are basically the amount necessary for optimal growth, and these are basically looking at the sufficiency ranges within the plant tissue samples, not the soil samples. So it basically, in this chart, which you do not need to know, just for your reference, it tells you the percentage of each. Now, this information allows us to develop site-specific nutrient management, which leads us into something called precision agriculture. Precision agriculture is the new wave of the future. Our farming equipment now is extremely high tech with GPS linking into our farming systems. We can get real-time data every few inches telling us what the nutrients are in the soil where we sampled, how much yield we've got from that point, developing GIS maps with that data, and we even have tractors now that we can send out without people in them based on a map we've developed of where we need planted, sprayed, etc. What this allows us to do is to actually only spray fertilizer where we need it in the low part of the field, or to plant at variable rates depending on soil ability to grow. It allows us to do the right thing at the right time in the right place in the right way. It's managing soil and crop variability in space and time. It's site and time specific soil and crop management, farming by the foot. Precision farming is conserving resources and saving our water resources as well. You already know what global positioning systems are. They've been around long. Yield monitoring allows us to actually determine which parts of the field by the foot what the yield values are. Instead of just an average yield value from an entire field, we know what this section over here is versus that section over there, which allows us to change the amount of fertilizer that we're adding in one part of the field versus the other. So we're not over fertilizing in the area that doesn't need it, and we're adding the right amount of fertilizer to the area that does. So how yield monitoring works is we've got a mass flow sensor and a moisture sensor and a GPS receiver with a task computer and user interface feeding information to the person operating the piece of equipment. And it provides us with a map that tells us where we have potentially bad yield data and where we have really good yield data so that we can figure out, hey, this area over here didn't yield the way it should. What do we need to do differently? We can also do soil fertility mapping for the different nutrients to figure out where we need to add fertilizer and where we don't. This conserves resources and decreases the over application of fertilizer. We can use the GIS to layer all of these maps to ultimately make better decisions. That's it, folks. If you have any questions, you know where to find me.